Welcome to the first video lecture for College Algebra, section 1.1. We'll be talking about linear equations and intercepts. If you haven't had a chance to, I recommend downloading and taking a look at the notes accompanying these lectures. They are available at the link down in the notes below the video. They are also available on Blackboard, as we mentioned in class. So in the interest of keeping these videos as brief as possible, I will not be rewriting any definitions or theorems, but I will refer to them in the notes by their number and by their page number whenever I can. So the section we're going to look at today, 1.1, the notes for that section are available in that PDF on page 19 and 20. And we're just going to do a few examples kind of illustrating what each of those ideas is talking about. So, the definition for a linear equation, the general form, is given in the notes. We will be working with a lot of different equations that can be manipulated to look like that. That form that we're talking about is ax plus by equals c, where a, b, and c are any real numbers at all, but at least one of either a or b is non-zero. So we'll begin by graphing. Since these equations represent lines, we can go ahead and graph one of these. I'll start with a nice easy one. We'll start with x minus 2y equals 0. And I'll do that by plotting a few points. Now, how I find those points, at least in the beginning, is a little bit tedious. Basically, what I need to do is pick an x value and then figure out what y value goes with it in order to satisfy this equation. And I can pick really any x value that I want. So I might make a table. I'm not going to do too many values because because lines are uniquely defined by 2 points. So I'll find 2 and then maybe 1 or 2 more. And I always like to start small, so I'll try x equal to 0 and see what y has to be in order for that to work. So my side work, if x is 0, then this is the equation that I have to solve for y. Alright? Now, since both sides are 0, or I have a 0 on both sides, that one's not really helping anything, so I can say negative 2y equals 0. And then if I want to solve for y, I can divide both sides by negative 2. And there it cancels on the left-hand side, and remember that 0 over anything is just 0, so I see that y is also 0 there. Okay, so I have 1 point. The point 0, 0. Let's try another one. If I plug in 1 for x, let's see what we get for y. So if x is 1, then this is the equation that I need to solve for y. If I move 1 over to the other side by subtracting 1 from both sides, I have negative 2y equals negative 1. And again, I can solve for y by dividing both sides of this equation by negative 2. Cancels out on the left, and I get y equals, now my negatives also cancel, so I just end up with 1/2. Now, the nice thing about lines is we don't always have to pick a value for x and then figure out what y has to be. We could go the other way and pick a value for y and see what x has to be. So if we let y be 1, what does x need to be? Well, then our equation becomes x minus 2 times 1 equals 0. In other words, x minus 2 equals 0. If we add 2 to both sides to isolate x, we get x equals 2. Alright, so those are 3 points on our line. We could plot all of those on the Cartesian plane, the basic xy plane. Alright, so 0, 0, starting from the origin, I don't go anywhere in either direction. 1, 1/2, if I come out 1 unit horizontally and I go up a half a unit vertically, I'll find another point. If I come over horizontally 2 units and up 1 unit, I'll get my third point. And we can see this behavior is going to kind of continue in either direction. So I connect those up with a line, and that is the graph of that linear equation. So as we saw in the previous example, that line that we ended up graphing crossed both axes, both the x-axis and the y-axis, in the same place. It crossed them at the origin, we call that point. So this line has one x-intercept at 0, 0, and it has one y-intercept also at 0, 0. If we were to just graph an arbitrary line on the xy plane, now I'm not going to label my axes, this is just some line traveling through our 2D space. I have my x-axis, my y-axis, and my line, we'll call it L. Some things to note about its x and y intercepts. So its x-intercept, the point where it crosses the x-axis, I don't know anything about this point, except that by virtue of the fact that it lies on the x-axis, that point is vertically unchanged from the origin. So this point has a y value of 0 and an x value of, we don't know. But that's a pretty big step, knowing that that point has a y-coordinate of 0. Similarly, this y-intercept over here, I don't know anything about where it is located, except that in relation to the origin, it is right above it, so it doesn't travel horizontally at all from the origin, which means that this point has an x-coordinate of 0. And some y-coordinate. We have no idea what it is. And that's going to be true of any y-intercept. Any point along the y-axis has an x-coordinate of 0, and any point along the x-axis is going to have a y-coordinate of 0. So that's a trick that we use, and we will use it frequently with all different types of graphs later on. To find an intercept, we let the opposite coordinate be 0 and see what happens, see what the coordinate in question has to be. So to find our x-intercept, we're always going to let y be 0 and see what that means about x. To find our y-intercept, we're going to let x be 0 and see what that implies about y. So let's employ that strategy to graph another line. It quickly becomes inconvenient to just find random points on the line, so we focus our attention on the line's intercepts because they're usually a little bit easier to find. So remember to find, I guess we'll start with our x-intercept, and I'll abbreviate it INT. What do we want to do to find this? Well, we let y equal 0 and see what that means about x. So that's half of the point that we're interested in. We have to find the other coordinate. So if y equals 0, my equation becomes 2x plus 6 times 0 equals 24. Alright. Now if I'm multiplying something by 0, then this whole term is essentially going to disappear, right? 6 times 0 is 0, and that's not contributing anything. So my equation then becomes 2x equals 24, and if we divide both sides by 2, we see that x equals 12 in that case. So we get the point 12, 0, and that would be our x-intercept. Now let me find the y-intercept. In a similar fashion, if I let the other coordinate, if I let x equal 0, then I get the equation 2 times 0 plus 6y equals 24. We can see something similar is going to happen when I multiply 2 by 0. Those are going to kill each other off, and I'll just get 6y equals 24. And if I divide both sides by 6, I see that y equals 4. So I get the point 0, 4. out of that process. And now if I plot both of those on the XY plane, I'll go over pretty far. So this is a little bit interesting. When you are laying out your Cartesian plane to graph something, it's always a good idea to know a few points that you plan on plotting so that you can scale your axes accordingly. For instance, I might not want to put 12 tick marks on the horizontal axis, on the x-axis, because maybe I don't have enough room, but if I have a tick mark stand for 3 units, if I say 3, 6, 9, 12, then I convey all of the relevant information, but I do so a little bit more concisely. Now, 4 is a pretty small number, so I might still have 1, 2, 3, 4 vertically and plot my y-intercept. Now I want to make sure I label these, because notice I have 4 tick marks appearing along the x-axis and 4 appearing along the y-axis, but they mean very different things. And if I connect those up with something like a line, we will be done with this graphing problem. Now, we will also be learning to use our calculators extensively in this course. So going back to that previous example, if we wanted to confirm our results by graphing 2x plus 6y equals 24 in the calculator, we would need to transform it into something like y equals and a formula on the right-hand side involving only x. So I can only plug in stuff involving x, and I'll show you how in just a second. So first, if I want to isolate y in this equation, I might move 2x over to the other side. So if I get 6y equals negative 2x plus 24, then I can divide both sides by 6 and isolate y in that way. So y equals, and I'll write the right-hand side broken up. So I have a fraction, negative 2x plus 24 all over 6. I could write that as negative 2x over 6 plus 24 over 6. And then I can clean things up a little. So y is actually equal to 2 can cancel with part of the 6. We would get negative 1 over 3x. And 24 has a factor of 6 in it, so this will cancel entirely and I'll just be left with 4. So that is what I am going to have to plug into the graphing calculator. Now to do that, I'll turn it on and go to the y equals screen. So up at the top left, you'll see a little y equals button. If we press that, we'll have a bunch of options for y's that we can type in. And I'll just use the first one. And I want to use negative, not minus. So there are 2 separate buttons for negatives and minus. So if I do negative 1 over 3, and x is up in the right next to the alpha button. And finally, plus 4. And to see that this looks like it should, I'll hit graph. And there we have our graph. Now you may need to adjust the window a little bit. At the moment my window goes from negative 10 to positive 10 in both directions. So if I would like to zoom out a little bit, or just modify how far out my window goes horizontally or vertically, I could either use the window button or the zoom button. So the window button is the one I'll actually use, and here you can see my x min is negative 10, that's the furthest to the left we can see. My x max, the furthest to the right that we can see, is also 10, with an x scale of 1. Now what that means is that every tick mark represents 1 unit. Alright, and we see the same type of situation in the y direction. So if I want my window to look very similar to how we graphed the initial version of this line manually, I could go from -10 up to maybe 15. I'm going to be able to see a little bit past 12, that y-intercept, or that x-intercept rather. And we had a tick mark every 3 units, so let's do the same thing here. Now I don't really need to mess with the y-min or y-max because my y-intercept is at 4, and that will already be visible. So if I hit graph again, we can see our graph crossing the y-axis there at 4 and the x-axis there at 12. And so that's how you're going to need to tweak things if you ever have to graph lines that don't fit nicely into that standard window. Now, one other trick that we can use our calculator to save us quite a bit of time in accomplishing is using the table feature. So again, back to the y equals screen, I still have my this version of the line typed in that we already graphed. Now, if I go to table, you'll have to hit second to shift up to that table feature. I can choose what x values I plug in, and then the calculator will populate that second column with all of the associated y values. Now, depending on how your table is set up, you might need to do a little bit of surgery. So currently, mine is set to auto. It's going to automatically decide what x values I'm allowed to plug in. So you can see I plug in 0, 1, 2, 3, 4, and so on. You can also set it to ask you what x values you're interested in. If you have strange x values to plug in and there's no really obvious connection between them or formula where you can tell how to arrive at them, you can just say, let me decide that. And then when you type them in, it will then calculate the y value associated with each one. So the way that you would set that up is by going to the table settings. So if you go second table set, you'll see the options are table start, and if you are set to auto in that independent category there, so that one is currently set to auto, that means the calculator is going to figure out what to input there. Now table start is going to tell it when to start counting. So if I tell it to start at 0, it's going to start at 0, and this second option, delta table, will tell the calculator how far apart these x values should be. So if I keep that at 1 and keep that at auto, we can see our table is going to look exactly like it did before. But I can be tricky with that, and I can tell it, how about you ask me what x values I'm interested in, rather than just coming up with your own. Then if I go back to the table, you see all of our x values are gone, and I can plug in the ones that I care about. So if I plug in x equals 0, there I get my y-intercept, 0, 4. If I plug in 12, another interesting point, I get 0, and that matches with our x-intercept. So you can plug in a few more points and make sure they look right. So if I plug in 6, I get 2, and that appears to lie right on the line that we graphed earlier. And if I plugged in, I don't know, -8, let's see what that gives us. It gives us about 6 2/3. So that is how you'll modify the table to your advantage if you need to come up with a table of values for some of the homework problems.